This fourth module is all about data science and how to visualize data to be able to extract information. This is especially valuable when you're doing some preliminary analysis of your data to see if you have the right data to answer the question or the data characteristics. So in the past lesson, we just reviewed how to generate some summary statistics. And there are many packages to help with data visualization. A very common one is Matplotlib. And you can see many examples here of and the source code for all of these. So one of the best ways to try to figure out how to create a plot is to look at examples, but we're going to review some of the most basic and simple commands just so you don't have to look those up. You'll know how to generate different types of plots. Okay, so Seaborn and then also Plotly. Plotly is also available in other environments besides Python as well. Okay, so we're going to cover some examples like time series, correlated variables, scatter, pair plot, and then data distribution such as bar, box, violin, distribution, and joint plot. So let's just generate, first of all, just go ahead and import some of the packages that we need. If you don't have Plotly, you may need to go and download it and install it. Just go ahead and insert a cell above or below and pip install Plotly, and that will install Plotly for you. Okay, and then just run this cell again just to make sure you've imported it. All right, now let's go ahead and generate some data. This is just going to be n linearly spaced values between 0 and -1. Okay, and with n values there. And we're going to create some normal and uniformly distributed values. And then we'll also have z in there as well. And then we'll put it all into a data frame. And we'll look at the first 500 and then the second 500 as well. Okay, so running this, here is W that says which set it belongs to. And if I look at the tail, the last of them, you'll see that these belong to the 500 to 999 set. Okay, let's go ahead and just create a basic plot. So this is going to be plt.plot, and then we'll show. Now, one of the things that you saw here is there's different commands like matplotlib inline, and that puts it right inside the window. If you just leave off the plt.show, it'll still show up, but then it has this text here that says what type of plot it is, because that's the last command you issued, so it's going to print that. So if you want to avoid that, just do plt.show. Okay, so there is just a regular line plot. Or just a regular plot that shows the data points connected with a line. Okay, there are different ways you can modify, for example, the color or the markers. And you can say, for example, color equals red, and then just change it to red. Or a shortened way that you can do it is say a red dotted line, for example, or a red dashed line. Or you could do a red dot, or a circle, or you could do squares, for example. So many different types of things you can do. The first symbol is going to be the color, the second one is going to be the shape, and then the line that connects them. Okay, so that one isn't easy to see. Let me see if that, okay, so you get the picture there with the different things you can do, or you can separate them out with color equals orange, for example, and then there's other things for the markers and the line style. Okay, so there are the line styles and different types of markers that you can use as well. Alright, so let's add, in this one we're going to do a subplot, and then we're also going to save the figure as a PNG file. we can make it transparent background and adjust the dots per inch. So at 600 it's a little higher resolution. And then if I run this again, I can see some of the data like the Z data and the X and Y. And I've just added a few other things here. I changed the figure size. So there I'm going to make it just a little bit wider. And this is how tall it is. And then I created a subplot 2, 1. That means how many rows and how many columns. And then this is the very first one. So it's the top plot. And I plotted it. I added a grid. And then I added a Y label and a legend. And then this is the second subplot. So a lot of it just repeated. And then I saved the figure. Okay, so if I just come here to the desktop, and I can see this figure, myfig.png. Okay, so if you want to change the file type, you can also change that here if you're submitting to like an academic paper. Let's see, this looks like partially transparent rendered opaque. Okay, so I might need to take that off for this one, or the DPI. It doesn't really go with DPI. Okay, so anyway, I can change it to JPG, for example, and save it as a JPEG or other type of file format just by changing the extension. All right, let's do the plot activity here. I'm going to insert a cell below. And I'm just going to copy these. Now we want to create a plot that displays the data. So plt.plot xtyt, and there you can see the plot. Now if you want to add some things like x label, and I'm just going to do y label as well. Let's see. X label, Y label, str not callable. Okay, I think I made a mistake somewhere. Let's see, I'm not sure where that is. Okay, so PLT, let's see if I can hone in on it a little bit more. String not callable. Okay, I'm going to pause this and then just resume once I figure it out. Okay, I figured it out. This right here, I just redefined X label up here for PLT X label. I should have put this instead of equals. I should have done something like time, but I redefined how I X label, so now it's a string, and I couldn't change the X label. You see that the X label is missing here. So I'll fix that. Okay, so just no X label for right now. Alright, so let's go on to scatter plot. Okay, so scatter plots are similar to regular plots, but they show individual points. I'm going to do this in Matplotlib and just create a scatter plot, and you'll be able to see, in this case, X versus Y. Okay, it looks like a spray or something, and I can also do this in Plotly as well. It's just a little bit more complicated, but this is like a Plotly Express. But the plot is much nicer. It's going to have something that's interactive. I can put my cursor over it and see the values. You can see the different colors there as well in terms of categories. The first 500 and the second 500. Okay, so very nice plot overall with Plotly. Okay, so scatter plot activity. Let's create a scatter plot. And in this case, we are going to use Matplotlib or Plotly to display xt, yt, and paired with yt and zt. All right, so let's go ahead and just do grab this. All right, and if I run it, I'm going to have an error because I can't multiply lists together. So just wrap it in an array call to make it into a NumPy array, and then you can multiply the elements together. Okay, so there we have no error. And then I'm going to go ahead and plot xt, yt with, in this case, we need squares for yt. And I'll just make a S with a line. And then we'll have xt and zt. And in this case, we need a triangle, which is going to be the upper caret sign. And then I'll make it a dashed line. Alright, so here are the plots. Alright, bar chart. Bar charts are nice to show histogram information. Here I'm going to show Y and Z, and just with a legend. Okay, I made it alpha. I put a little bit of transparency on that one so you could see through it. If you don't put that in there, then it's just going to block the other one. You can't see it quite as well, so I always like to use about an alpha of 0.7. Okay, 0.3 is just a little bit too faint. 0.5 as well. I just think it's a little too faint. I like somewhere around 0.7 for that value. Okay, let's go on to a bar chart, bar plot activity here. Okay, so here we have the data, and this is random values. All right, and then we want to be able to plot them. So I'm going to use bins here. These are the number of bins I want to create. Okay, the different values. And then I'm going to add my histogram. And this is going to be xt, and these are going to be the bins, and I'll label it xt. And add these as well for yt and zt. If you want to throw in some alpha values in here, then you can see through them just a little bit better and see what is see the x and the y values. All right, and then if you do the plt show, then you can see a little bit better. Okay, so uniformly distributed, normally distributed, and then a multiplication of the two. You can see where they intersect. It's skewed just a little bit to the side. It's about, well, actually the green is about uniform as well. All right, let's go on to the next one, a pair plot. A pair plot shows a correlation between variables. So each of these plots has different things that it's showing. Some of them just show distributions. In this case, it's going to show you how they relate to each other. And this is useful to be able to see correlation. So for example, here's the first 500 and second 500, the distribution. And then it shows the distributions of y versus z, y versus y. So the ones right along the diagonal, those are going to be the distributions of itself. And then the ones that are on the off diagonal, those are going to be symmetric. So the one up here and the one down here are going to be basically the same. And there's a feature that you can do just to turn on just the bottom left, because those are the only ones that are really unique anyway. You're just kind of flipping them sideways to be able to look at it the other way. Okay, so let's go on with a pair plot activity. We want to create a pair plot that displays the correlation between x, y, and zt, okay, between the first 500 and second 500 random numbers. And we'll create a custom pandas data frame with this code. So I'm just going to go ahead and copy this down into the cell and run it. And then I want to be able to create a pair plot now. All right, so SNS, and that will be a pair plot. And this one's going to be the DT data frame. And the ones that I want to select are XT, YT, and ZT. And then I'm also going to throw in DIST as well. Okay, those are all of them. I really don't need to specify them, but if you have a bunch of values in your data frame and you only want to select a subset of them, you could use a list like this to just select just the ones that you want to show on this plot. Okay, hue is going to be the value that's going to distinguish them. Okay, here's my pair plot between the first 500 and second 500, and you expect them to be fairly similar, okay, because I'm doing just random distribution between them. Okay, so it shouldn't have any number dependence, but has a little bit there. All right, let's go on to a box plot. A box plot shows quartiles, and especially it's useful for showing outliers. I'm going to run this, okay, just with the first 500 and second 500 for X, and so W is the classification down here on 0 to 499 and 500 to 999, and then Y is our X value, and that shows the box plot. Okay, so this shows the different quartiles, the middle quartiles, and then the upper and lower. You'll see values, points if it, they're classified as outliers, potential outliers. All right, so we want to create a box plot that shows the quartiles, okay, of YT by the first and second sets as indicated in DIST. So let's do SNS, Seaborn box plot, and I want to say X is going to be my DIST, that's going to be the thing on the X axis, and then Y is going to be a YT, and then data is going to be the DT value. Okay, and then I'll show this, and there's my box plot with a couple potential outliers that are identified. Okay, let's do a violin plot now. Violin plot's nice because it shows the quartiles, but also shows the distribution on the same plot. So you see that, right here it's the same distribution, but in this case it also shows the, this, which is the distribution, not just the quartile information. All right, let's show the violin plot. The quartile is a distribution of ZT by first and second sets as indicated in DIST in the frame DT. Okay, so this one's going to be SNS, violin, and X is going to be DIST, and our Y is going to be ZT, and then our data is DT, and I'll just say size equals 6. You can adjust that size. Okay, let's see, violin, oh, it's not violin, it's violin plot. Okay, so you can see the distribution there. Okay, the next one is joint plot. All right, joint plot shows only two variables with univariate joint distributions. Okay, so I'm just going to show this. It shows the variable 1 versus variable 2. It shows this type of map, like a contour plot. It also shows the distribution of X up here, and it shows the distribution of Z right here. So it's both a one-dimensional distribution here on the sides, but also in the middle, this is a two-dimensional distribution as a contour plot. And you can try different types. So you can have hex, for example, and it shows the concentration just with a hex map, or you can do REG for type of regular plot. Okay, just show the points on there, and the clustering, you'll just be more dense in the areas that are more clustered. Okay, let's see, let's go on to the joint plot activity. So we're going to do this one ourselves now, and this one is SNS joint plot, and we want to show the distribution of YT. It doesn't really matter what order you put these in, it's going to show you the same information, and data is going to be DT, and I'll just say kind equals KDE. Alright, so here is my joint distribution plot. Alright, let's go on to the TC lab activity. This one's going to collect some data. I'm going to go for 120 cycles. I'll just write with the CSV file, There's my header to print. Okay, every 30 seconds, I'm just going to change the heater values to a random number between 0 and 80. And then I'm going to write the row each time. And every 5 seconds, I'll print out the row. I'll sleep for a second. And then finally, after I finish, I'll go ahead and read that in again as a data frame. And if you don't have a TC Lab, you can just, you'll notice that you're not connected, and it will basically just grab it from this same data file that we used before. All right, I'm going to go ahead and start this. Okay, and let's just build our graphical analysis as this is going. You know what, I'm going to interrupt this and let me do this. I'm going to change this to only print out every let's say 20 seconds instead, just so I can keep an eye on the measurements, but I don't want it to keep printing out and shifting me down. All right, let's go ahead and just create a new figure. I'm going to do plt.figure, and I can set the size, fig size equals, and 12 by 5, for example. All right, and then I want the first subplot where I just want to show the time series information, and this one is just going to be a plot of data 4. It's going to be coming out, and that will be time, and then data 4, and then let's do Q1. All right, and then we're going to have that be a red dashed line, and I'll just give it a label, and this will be Q1. Okay, I'll copy that and do Q2 as well. Make this maybe a blue dotted line, and just change it to Q2. All right, let's do the next one. Actually, I should just probably copy this whole subplot here. And I'm going to go on to the second subplot. That's going to be the lower one. And this one's just going to be T1 and T2. I'll just keep the colors the way they are. Okay. And let's see. Let's go ahead and just show this plot. All right, there's our first one. The other one that we want to construct is a pair plot that should be a 2x2 plot grid that shows the heater temperature pairs. So we want to show the difference between heater 1 and temperature 1 and heater 2 and temperature 2. So this one's just a little bit trickier. We've got to stack these on top of each other and mark the different data sets as such. Okay, so I'm going to split these into, let's see, data 4 is going to be my data frame. I'm just going to take Q1 and T1, and I'm going to make a copy of that data frame. And I'll do the same thing, but with, I'll put B there, and that's going to be the second one. All right, and then I'm going to rename the columns. Columns, I'm just going to make those both the same. So this is going to make it easy to create this plot. And I'll do that for A and for B. Okay, just rename them as Q and T. But I want to make it realize that the first ones, the set, is going to be, I'm going to put a non-numeric value here, so string heater 1 and then heater 2. Okay, and that's going to be for D4B. Then I'm just going to stack them on top of each other. Okay, and that's going to be pd.concat for concatenate, and I'm going to put D4A and D4B just on top of each other, and when I do that, I'm going to ignore their prior index values with index equals false. All right, and then let's go ahead and just do D4 head just to be able to look at this. Okay, so here is my data. It looks like I had a little bit of an outlier here right when it went up in temperature. Okay, and you can see I have Q and T and heater 1, and if I look at the tail, okay, I can see that I have my heater 2 values as well. But let's create a pair plot now. Alright, I'm going to insert a cell below, and let's just create SNS pair plot, and this one's going to be D4, and I can just use all of the data rows there. I don't need to just separate out just the ones I want, and I'll do show. Alright, so here shows how the temperature differed between heater 1 and heater 2. Here you can see T versus T, and then Q versus Q up here, and then some of the values. Okay, and you can see that Q just went to kind of discrete values, so it's just up and down. Okay, as it moved, heater 1 or heater 2 just had these discrete levels that they went to, and then you can see the temperature rising on these. Okay, so this is a pair plot. We've shown in this tutorial, we've shown a number of different plots. It went really fast. Basically, the message is you can use plots to be able to show time series data. You could use plots to show distributions. You can use them to show correlations between different variables, how they're related, if there's a good linear relationship between them. And there's many other types of plots that you can create to be able to harvest some information that we're going to be using later, like generating features for regression or classification. Which variables, which features are going to be able to help us classify an image or some outcome that we're trying to predict. So visualization is a very good way to do that, especially with initial data exploration.